Okay, so I showed you some basic additive synthesis previously. A more sophisticated additive synthesis example is here. We're still just taking sine waves and adding them together, but we have a more sophisticated patch here which combines sine waves together in more complicated combinations. So let's turn on the sound. So what you're hearing there, even though it might not sound like it, is really just clever combinations of sine waves. And next week we're going to be talking about Fourier transforms and the theories about how any kind of regular sound can be resynthesized given enough sine waves if you add them together. And so this patch is giving you a sense of that, giving you a sense of how complex the sounds you can get really just by combining simple sine wave oscillators together. The last example I wanted to show was attack, decay, sustain, release. So I'm just showing you this because I think in the labs, when you start to mess around with making your own sounds and hooking them up to your PD patches and your assignments, you're going to want to trigger notes. So rather than just make a continuous sound, as nice as that can be, rather than just making continuous sound, you're probably going to want to kind of trigger a note or some sonic sound and have it attack and sustain and decay and release like regular notes do. So attack, decay, sustain, release is a very common way to describe a sound in synthesis language. So the attack is the beginning of the note, how quickly or sharply it begins. Decay is how the shape of how it falls away from that initial attack. Sustain is how long the note sustains for, how long it lasts for after that initial sort of attack and initial decay. And then finally the release is how it transitions back to silence again. And a useful object for doing this kind of thing in PD is the V-line object. So with V-line you send it a series of numbers. If you send it, and what you're doing is specifying a target value and a time to get to that target value. So if we just look at these first two numbers going into V-line here, we're saying to it, okay, ramp up to the value of 1. So from whatever value you're on now, by default, and initially it'll be 0, from whatever value you're on now, if it's initially 0, gradually ramp up to the value of 1. So go from 0, 0.1, 0.2, 0.3, and all the numbers in between, ramp up to 1 over a time of 200 milliseconds. So that's what the first pair of numbers tells it to do. And then the next three numbers say, okay, now you're at 1, ramp down to 0.2 and do it over 500 milliseconds. But before you go to 0.2 over 500 milliseconds, wait. So in other words, we're jumping up to the value of 1 we're ramping up to a value of 1 over 200 milliseconds. We're staying at that value for another 100 milliseconds, and then we're going to go ramp down to 0.2 over the time of half a second. Then the next three numbers are saying, okay, now go back down to 0 again over 800 milliseconds, but wait for 600 milliseconds to do that. So what we're doing, and it might be a bit hard to sort of get a sense of what that means just from looking at the numbers, but we're jumping up reasonably quickly over 200 milliseconds, 1/5 of a second. We're ramping back down to 0.2 over half a second, 500 milliseconds, and then we're fading out over to 0, to silence, over 800 milliseconds, so nearly a second. And what we're doing is, so V-line's just basically sending the numbers between 0 and 1 out its outlet based on the shape that we're specifying there. And all we're doing is we're taking the output from our oscillator, and we're multiplying it by that value. And actually, I'm just seeing there's a mistake there. Can we quickly fix this up? I shouldn't have put that there. I should have put it there. So this is the more or less the hacked version of the FM synthesis patch I showed before. So we're taking the output of the oscillator and we are feeding it through a times object, and the value of that times object is set by the numbers coming out of V-line. So what I hope is going to happen is that we're going to, when I hit this number, we're going to kind of get a note with a particular, with a shape that I've specified with these attack, decay, sustain, release parameters over here. So let's see if I've actually done this correctly. No, I haven't. Ah, I know why. Maybe some of you will have spotted why. I'm not getting that because I haven't set any values up here. So first let's set our oscillators to have some values which are reasonable, at least which are going to make some noise. There we go. So there we go. So we've got a basic note coming out there, which I'm triggering with those attack, decay, sustain, release values. If I send, and of course, if I send in other attack, decay, sustain, release numbers, I put in something here where we've got a much sharper attack, what are we doing here? Yes, sort of a slightly louder sustain and the same decay, more or less. So again, I'm not sure quite how loud that's coming through on the video, but you should hear that one. That note has a much gentler start to it. Yeah, so hopefully you can hear that coming through. We've got, by specifying different numbers in here, you can specify sort of different shapes to the sound that you're generating. So hopefully you can use that in your patches, those basic building blocks, to create some quite interesting and appropriate sounds for the projects that you have in class. I hope that's been useful. In the lab, we're going to be practicing applying all this, and we're going to be hooking up our processing sketches to some basic audio synthesis in Pure Data, which I hope should be fun. So I'll see you there.